and determination of lattice constant. Aim: conduct an investigation on the powder X-ray diffraction pattern, that is PXRD pattern, of a given unknown crystalline material and determine its crystalline phase and lattice constant. The apparatus required are the readily available X-ray diffraction patterns of few polycrystalline substances, Miller indices comparison chart, and laboratory stationery. Formula: the lattice constant of a given unknown cubic crystalline sample is A is equal to lambda by sine theta into root over h square plus k square plus L square, where lambda refers to the wavelength of the X-ray source used in the experiment. Here we are assuming it to be a copper K alpha source whose wavelength value is lambda equal to 1.5406 angstroms. Theta refers to the glancing angle, that is the angle made by the incident X-ray beam with the crystallographic parallel planes of atoms, that is theta. H, K, L here refer to the Miller indices of the parallel planes of atoms. So here the lattice constant is measured in angstroms. Now this is a sample X-ray diffraction pattern of an unknown crystalline sample. Now here it is a plot between intensity of the diffracted X-ray beam from various parallel planes of atoms and twice the glancing angle on x-axis, and on y-axis is the intensity of diffracted X-ray beams from various parallel planes of atoms, which is measured in counts per second. Okay. On this pattern we can observe this Bragg diffraction peaks are observed. You can see this is one of the Bragg diffraction peak arising from a specific parallel planes of atoms. This is another Bragg diffraction peak arising from another parallel planes of atoms. This is the diffraction peak arising from another parallel planes of atoms, and so on and so forth. And you can see that among all these peaks, this peak is having highest intensity. So this means that this is the most preferred X-ray diffraction among this peak, which is having the highest intensity, refers to the most preferred orientation of atoms inside the crystal. Right. Coming to this observation table, we can look over here. This is the peak 1, peak 2, peak 3, peak 4, 5 and 6 and so on. So these peaks are numbered in such a fashion: first diffraction peak, second diffraction peak, third, fourth, fifth and sixth. These are the various diffraction peaks, and these 2 theta values correspond to the Bragg angle of diffraction. Here you can see that the peak having highest intensity, that is peak number 1, is the angle of diffraction value 2 theta corresponds to 44.53 degrees. So this could be around 44.53 degrees. This could be around that value. And the second